Each discrete random variable can be described, and to do that we need to specify first of all the values that the random variable can assume and the probability associated with each value. So let's go back to our first example where two coins are tossed simultaneously, and we already decided that the random variable of this experiment is the number of heads observed. So the probability of observing 0 heads is the probability of having 2 tails, which is 1/4. The probability of having 1 head is either observing 1 head and 1 tail or observing 1 tail and 1 head. Therefore, we're summing, since this is an OR situation, we're summing the two respective probabilities. So 1/4 plus 1/4, we get that the probability of having exactly 1 head is 1/2. And the third option is having 2 heads. So this is equivalent to the probability of having 2 heads, which is 1/4. So in this case, once again, the random variable is number of heads observed. The possible outcomes is 0, 1, and 2, and here we've got their respective probabilities. So this information can be put in a table. So in the first column we put the outcomes 0, 1, and 2, and in the second column we put their probabilities 0, 1/4, 1, 1/2, 2, 1/4. So this is one of the ways that probability distribution can be presented. It's called a tabular form. And we can also present the data in graphical form, and here are two possibilities. We can either have point representation or we can have histogram representation. So on the horizontal axis we put outcomes, on the vertical axis we put the probabilities. So the probability of 0 heads is 1/4, so we draw a line all the way to 1/4. The probability of 1 head is 1/2, so we draw the line all the way to 1/2. And the probability of 2 heads is 1/4, so we draw the line all the way to 1/4. And histogram is made in a similar way. So for 0 heads, we've got the bar all the way to 1/4. For 1 head, we've got the bar all the way to the probability of 1/2, and for 2 heads, we've got the bar all the way to the probability of 1/4. So as you can see, probability distribution of any discrete random variable can be either a graph, table, or formula that specifies the probability associated with each possible value, each possible outcome that the random variable can assume. And there are 2 requirements for probability distribution of any discrete variable, and it is similar to the properties of probability in general. First of all, the probability must be higher or equal to 0, and we already know this. The probability cannot be negative. And the second property is that when we sum all the probabilities for a certain random variable, in total we get 1. So if we go back to our example and if we sum 1/4 plus 1/2 plus 1/4, what we get is 1.